Okay, so today is 19th November and we will discuss to solve NLPP problems with graphical method. You already know the LPP problems, uh, they are to be solved in graphical method. You have already solved it, the LPP problems with help of graphical method. That's why you have the idea. Now in NLPP problem, either one of the equations like either the objective function or the constraints, any one of them are at least one of them will be a non-linear. So in this problem here, we will start with an example and the same procedure to be applied in all the problems. The problem is minimize z is equal to x1 square plus x2 square. Okay, so now this will be subject to constraints. Constraints are x1 plus x2 greater than equal to 4, 2x1 plus x2 greater than equal to 5, and x1 and x2 both are greater than equal to 0. Now if you look at it, this x1 and x2 greater than equal to 0, that means if we draw a graph, what it will look like, you know the procedures. So first we will write these constant equations as equations. X1 plus x2 is equal to 4, we will write, and 2x1 plus x2 equal to 5. Now we will plot them in a curve. We will plot them in a curve. So these both are linear equations. Let us draw a graph. Now we can take a centimeter scale. Okay, so each of the lines to be taken is 1 centimeter. Let me find my ruler so that we can draw 1 centimeter. Give me small time, I forgot to bring it. Okay, I forgot where it is. So I am just giving you the procedure. You remember me when you do it. You take a ruler and draw each small unit in the reference lines should be of 1 centimeter. 1 centimeter will be 1 unit. So if this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, 9, and 10, and so on. Here also this is 1, 2, 3, 4, 5, 6, 7, 8. So no graph paper is required on solving these problems. Okay, you can do it on your own using a ruler. So in exam the graph paper will not be provided. So you will do it with your ruler. Now if we look at the equations, x1 plus x2 equal to 4 and 2x1 plus x2 equal to 5. Okay, so now we have to plot them. Now if we take x1 plus x2 is equal to 4, this equation, then where we can say that this is a equation of a line, and this will uh, cross this x-axis, and this is x1 axis and x2 axis at certain point. So if we put x1 equal to 0, that means it will intersect the x1, and then x2 will be found out. So x1 equal to, putting x1 equal to 0, it will intersect at x2 axis. So if we put x1 is 0, then x2 we get as 4. So if we make a table of values of x1, x2, x3, only two points are required to draw a line. So one point we get is x1 equal to 0 and x2 equal to 4. And similarly, if we do this, we put x2 equal to 0, then we get x1 equal to 4. So x1 equal to 4, x2 equal to 0. So at 0, 4 and 4, 0, the line will intersect in these two axes. So this is your 4, this is your 4. So now we have to join them. So I do not have the ruler with me, so देसी जुगाड़ लगाना पड़ेगा. Okay, so this is the, you just understand that this goes with uh, this goes with in this way. So this is our constraint 1, and in short we will just show it with x1 plus x2 is equal to 4. Okay, this point is 0, 4, and this point is 4, 0. Okay, so we got first constraint. Now our job is to get the second constraint. So the second constraint is 2x1 plus x2 greater than equal to, sorry, this is already we have taken equal. So what are the significance of greater than signs we will discuss. Just let me do this, where this 2x1 plus x2 equal to 5 lines intersect. So if we put x1 equal to 0, then we get x2 equal to 5. So 1 point for the second constraint we get 0, 5, and for the other case, if we put x2 equal to 0, then x1 will be equal to 5 by 2. So x2 equal to 0, x1 will be 5 by 2. So this is the 2 points. So first point is 0, 5. 0, 5 is here, and the second point is 5 by 2, 0. It is along here. Okay. So now we have got two different points to join. So 5 and 2, 5. Okay, so we have got this other constraint. This is the line of the second constraint, that is 2x1 plus x2 is equal to 5. Okay, so these are two different lines. Now it said this constraint here, we can see x1 plus x2 greater than equal to 4. That means the feasible region in the outer section. So that means this outer section of this first line. In the second case also, this 2x1 plus x2 greater than equal to 5. That means in the second case also, this feasible region in the outside unbounded section. Okay, so the feasible region is the outer section. So the object will somewhere lie in this feasible region. So this is feasible region. Okay. So and also we can get sure that x1 and x2 greater than equal to 0. So that implies that this feasible region should be on the first quadrant. Okay, so we can understand that the object will be on this line or outer side of these two lines. So this is actually feasible region. Now we have to find the point where this z is minimum but will satisfy this condition. That point should be on the feasible region. So we need to find a point where the value of z is minimum and the point should lie on the feasible region. Okay, so now if we look at the z, z is x1 square plus x2 square, and it is similar to a circle's equation. Say z is equal to x1 square plus x2 square, which is also is equal to k square. So this actually gives the equation of a circle. So now the radius is k and we do not know the radius, and the circle is centering on the origin O 0, 0. Look at the figure, look at the equation of the circle, and you can understand that the equation is a circular equation and the center is at origin 0, 0 and its radius is k. Now the point is we need to find out the minimum value of z. So z might be like this. Arbitrarily it will be like this. So this circle, if the radius get increased or decreased, this parallel of this circular line will generate. Now we have to make a circle which will lie on the boundary of the feasible region. That means either on line 1 or on line 2 or on this intersection point. So in such a case, then our minimum value of z which is satisfying these constraints can be found out. So this circle and the radius to be increased in such a way that this circle touches the feasible region. Now when we increase the circle might touch the second constraint or the first constraint line or the intersection of the line. So let us check. So suppose we are assuming that this circle, which is x1 square plus x2 square equal to k square, this circle, which is the objective function, touches our constraint 1. So then if the circle touches the constraint equation 1, then it will be as such that at that particular point, at the intersection point where the circle touches the constraint 1, the constraint 1 will be the tangent of the circle at that point. So in such case, at that particular point, the slope or the tangent of the circle and the slope of the constraint will be equal, or you just say the gradient of the line and the gradient of the circle will be same at that point. So we are assuming now the second part. Let us assume that the circle touches constraint 1. So in such case, the gradient will be same for constraint 1 and the circle. So what is the gradient? Gradient we know is dy dx. So here if we talk about the circle, it is x1 square plus x2 square equal to k square. Now to find it out, we'll differentiate it with respect to x1. So it will be 2x1 plus 2x2 into dx2 dx1 will be equal to 0. From here we found dx2 dx1 is equal to minus x1 by x2. Okay, we give it equation 1, and for the constraint 1, it was x1 plus x2 is equal to 4. If we do the same thing, 1 plus dx2 dx1 equal to 0, or dx2 dx1 is equal to minus 1, we put it on 2. So in that case, this circle touches the constant 1. So at that intersection point, this value will be equal to this value. So now if we put it at, we'll write at intersection point of objective function, which is the circle, and constraint 1, which is the basically line 1. These two values minus x1 by x2 should be equal to minus 1, or we can get x1 is equal to x2. So we remember that. So at that particular point we get x1 plus x2 is equal to 4, and as well as x1 is equal to x2. So this on solving gives x1 equal to 2, x2 equal to 2. So the point is 2 comma 2. Okay, now the second case, let us assume the circle touches constraint 2 or the line 2. So in such case, this line 2 is 2x1 plus x2 is equal to 5. So upon derivative we get 2 plus dx2 dx1, which will be equal to 0. So dx2 dx1 is equal to minus 2. We point it as equation number 3. Now if the circle touches with constraint 2, so then the value of dx2 dx1 of the circle, which we found earlier from equation 1, we got minus x1 by x2 is equal to minus 2. So from here we get x1 is equal to 2x2. Now we get two different equations. One is 2x1 plus x2 is equal to 5. Another one we got x1 equal to 2x2. Upon solving them we get x2 is equal to 1 and x1 is equal to 2. So the point is 2 comma 1. So we have got 2 points, 2 comma 2 and 2 comma 1. So we have to check of these two whether in which value the z is minimum, and as well as whether these two conditions are satisfying both of the constraints. Now we remember the points 2 comma 2 and 2 comma 1 and get back to the curve. Okay, so 2 comma 2 and 2 comma 1. Now if we look at it, if we look at the circle, if we have drawn it properly, then we will find this 2 comma 1 is here, which is not on the feasible region. Okay, 2 comma 1 is, it's very clear, is in here. Sorry, not there, is here. 2 comma 1, not this. 2 comma 1 is here, 2 on x1 axis, 1 on x1. So this 2 comma 1 is not on the feasible region, because the line should be on this feasible region. That means either on this line or on this line. So this point 2 comma 2 is shown that on the constraint 1 line. So this circle will be touching I have not drawn it properly. That's why the problem is. So it will touch in about here at 2 comma 2, and so this will be the optimum point which is satisfying the constraints and as well as the z. So the minimum value of z is equal to x1 square plus x2 square, and putting the values is 2 comma 2 is 8. So z minimum we get 8. So is the method clear to you?
Yes, sir. ড্রয়িংটা আরেকবার বলুন না, ওটা 2,2 কি করে হচ্ছে?
কোনটা?
2,2 ওটা তো স্যার আমি যদি সেন্টার পয়েন্ট থেকে নিই তাহলে সার্কেল আঁকলে ওটা কি 2.2 তে হবে অ্যাকচুয়ালি?
2.2 তে তো হবেই, তার কারণ 2.2 টা কোথায় আছে দেখো, এই যে x1 প্লাস x2 টু দি ইকুয়াল টু 4 এই কনস্ট্যান্টের উপর আছে তো।
হ্যাঁ হ্যাঁ হ্যাঁ, ওকে ওকে।
ওটা তো হবেই, মানে ড্রয়িংটা তোমাকে একটা স্কেল নিয়ে মেপে চুপে করতে হবে, নাহলে হবে না। আমি তো what I have done here is I have arbitrarily taken 1 centimeter is equal to 1 unit, arbitrarily taken. This is not 1 centimeter, there are differences. So that's why the drawing is hazy, but you have to draw it with proper rule and with proper scaling, and this should be properly perpendicular, and this all the gaps should be of 1 centimeter each, and you have to write that in on each axis one smallest gap or one smallest unit is as in figure is 1 centimeter. And then if you draw the points properly and draw the lines properly, then you will get this will occur, because this is the mathematics. This 2.2 shows that this will be on x1 plus x2, but if you take 2.1, this will be on this constant, but that will not touch the first constraint, and that will not be on a feasible region. যেটা দেখো আমি রাফ করে গেছি, কিন্তু স্টিল তুমি বুঝতে পারবে যে এই পয়েন্টটা কিন্তু সার্কেলে যাবে না, কিন্তু এই পয়েন্টটা যেতে পারে। So if you draw it with proper dimension, you will find it. In my rough dimension also it is clear that this is 2.1 and this is not optimum, because this is not in feasible region.
হ্যালো স্যার।
হ্যাঁ বলো।
হ্যাঁ স্যার, 2.2 চলে আসবে স্যার, কারণ স্যার ওই দুটো স্টেট লাইনে স্যার ইন্টারসেক্টিং পয়েন্ট হচ্ছে 1,3
1,3 মানে আরেকটু উপরে আসবে, এরকম জায়গাতে আসবে, এরকম জায়গাতে আসবে। তো if you do it properly, then you will find that your graph is working. No graph paper will be provided. I am repeating it because in last time I have done this type of problems in Blackboard without graph paper, but in exam some people wanted a graph paper. Now, of course it will be not provided. You have to do it in your copy with rulers. Okay, so is the method clear how to solve the graphical problems?
Yes, sir.
Okay. Now, as you can understand that in this class, we cannot cover multiple problems, but if any problem occurs when you are practicing, then you must send me through any medium and I will solve it and I will give a reply on your problem. So in your home, it is your job, it is your responsibility to solve sufficient problems from different books. And Hiragupta is a soft copy provided to you by our AKR sir, and that book is quite sufficient. You will get the idea on several problems that how they are solving it. There are another method too, like you take a compass and if you take a compass and increase the compass radius and start to draw the circles, and if you increase the radius you will find at one point that circle will touch any one of these constraints, and you draw the circle and you can geometrically find out the value of the point, and you will find that will be very close to 2.2. If you do it totally graphically, then you will find it is about 1.97 to 1.97, about 1.9 to 1.9, like this. Okay, you will get plus minus zero point 0.1 difference if you are right. That is another method you can do. So you take a compass, you just go on increasing the radius and start making circles, and the point the circle touch with any one of these constraints on the feasible region, then you get your point. Now you find out with help of rulers again that the coordinate of the point. What I am asking is take a compass with pencil and draw circles and go on increasing its radius. At a point it will touch any one of these two lines on the feasible region. Where the circle touches the feasible region, you stop there and you mark the point, and you make this x1 value and make this x2 value, and you will get your point. That is also another method, and that will be very close to this one, because when you are doing it graphically, totally 100% graphically, then almost correct answer, exactly correct answer is quite impossible, because it is impossible to do a correct graph manually. So if you get 1.9 or 1.88, 1.88 is not possible, you will get either 1.9 or something. So then also your answer is will be taken as correct if you do it totally graphically. Okay, any questions on this?
No, sir.